everyone. My name is Jeff Rio De La Rey, a student from Gordon College who is also taking a bachelor's degree in computer science, and I welcome you in this video of C tutorials. And for this video, I will help you understand what is memory management in C is, basic syntax, and how it is implemented in a program. Let's get started. Alright, so memory management in C, our topic for today is what is memory allocation? What are the two types of memory allocation? What is a static memory allocation? What is dynamic memory allocation? And the four functions or operations that we use under the dynamic memory allocation. So first, what is memory management? So in C programming, the memory is allocated to all the variables of the program automatically during compile time. But sometimes we have to reallocate a memory or to resize an array. Therefore, we must allocate memory during runtime. So that's where the two types of memory management in C comes in. So in static memory allocation, memory is allocated at compile time, and the size is fixed throughout the program's execution. So meaning here, once we set up the variable, once we run the program, it will no longer be able to change anymore. So it is what it is. Whilst the dynamic memory allocation is a memory management technique that allows memory to be allocated and deallocated during runtime, providing flexibility in terms of its size and usage. So it's interchangeable during runtime. So I will go more deeper in the dynamic memory allocation as we go on. Now let's dwell deeper with the dynamic memory allocation. So what is dynamic memory allocation? Dynamic memory allocation is an operation you're going to perform at runtime or during runtime to allocate an arbitrary amount of memory at arbitrary points in your program. There are four functions that generally deal with memory allocation and deallocation. The first one's these four: the malloc, calloc, and realloc, and then three. Well, the first function, which is the malloc or malloc, it's the simplest of them all. It takes only one argument specifying a number of bytes and size to allocate a pointer to the beginning of the allocated memory. And malloc memory is uninitialized, meaning it could contain anything or nothing at all. When we have here the calloc, it is almost identical with malloc, except the allocated memory is 0 initialized, and the arguments are slightly different. We'll get into that later on. So we have the realloc, that's reallocation function. So it is used to reallocate an existing memory allocation. It expects argument 1 to be the pointer to a memory we previously attached or allocated with a malloc or malloc. If the argument 2 would be the size that we are going to reallocate in bytes, in the size of the bytes we are going to reallocate on the previous one. And if a null pointer passed through realloc, it will function the same as malloc. So here the last one is free. It is simply used to deallocate memory and return it back to the system for use elsewhere. And also it is used to avoid memory leaks and memory with garbage values. Now let's further explain this and try and implement it in a compiler. Alright, so I have here a sample for our four functions that I mentioned earlier. So I have added the standard library.h so that we can get access to malloc, calloc, realloc, and the free function. In the beginning of my code, I use the fail function. All it really does is to print that the memory allocation had failed in case the memory allocation had failed, of course. And here is the first example of malloc. So I have added a variable called name appointed to the data type character and called in malloc, passing it through this, to our first argument, which is the size and bytes. And here I have initialized the value of 17. Why 17? Because I have 16 elements here by using computer science, and one element for the null terminator, and I multiplied it to the size of the data type character. Size of the data type character is 1, so 17 multiplied by 1 is also 17. So basically I could have just used 17 over here, but it is a good practice to always multiply your data type bytes to the data type. So here is an if statement just to make sure if the memory allocation was successful, and here is the string copy function. It is just to simply copy the string computer science into the allocated memory, and again we are going to print the result just to verify that our program is working. And then again, free name, the free function, as what I've explained earlier, it is used to deallocate and send back the memory back to the system for use elsewhere, and also it is to avoid memory leaks and garbage values in the program. Here is the results of our program. As you can see, it says name and then the computer science. Alright, now let's move forward to the second function that we have, which is the calloc. So as you can see here, I have initialized numbers variable and appointed to the integer data type. I've pulled out the calloc, plus it should 2 arguments, 2, which indicates the size of our elements and size of our data type, and then initialize an if statement on our line 14 just to make sure that our memory allocation was successful. And on the line 19 and 20, we are assigning the values of the array elements, which is on index 0 we have 1, on index 1 we have 2. Basically you can put any values in this case, but I just use 1 and 2 for example. And then we are going to print out the array elements just to make sure that if our memory allocation is correct. And then the last part would be free function, just to make sure that all the allocated memory is deallocated once it's done. So if you are to run this program, here it will show you the array elements that we have. So we have 2 elements, and then we had 1 and 2. Okay, then moving on to the last but not the least function that we have, which is the realloc. As you can see here, I have used the code earlier for the malloc for the computer science. And now we will try to reallocate the memory for a larger string. And here, as you can see, I have called in variable, pointed the name variable to, and called out the realloc, and then pass it to 2 arguments, which is first argument would be the name that we appointed as variable on our malloc, and then change the size and bytes to 30. Why 30? Because we added an extra 13 more letters for is the best here. And again, if statement, just to make sure that our new memory reallocation is successful, and then we are going to print the final result. Let's try and run this actually. Let's see, here we go. As you can see here, the initial name was computer science, and then the final name is computer science is the best. As you can see, the string is now larger because we were able to add the is the best. So that's pretty much it for the reallocation. And before we end this video, I would like to do a short recap. So today we have learned about memory management. We have learned the difference between static memory and dynamic memory allocation. We have learned how to implement the 4 functions, which is the malloc, calloc, realloc, and the free function. And again, my name is Jeff Lirio de la Rhea. Thank you for watching this video, and I hope you learned a lot today.